Hi, welcome to some more great news. The hits just keep on coming. It's the alpha release of H4AsyncWebServer. If you do want to be an early adopter and have a bit of a play with what's been released so far, you will need to download manually and install the libraries shown here. And until the H4 installer is ready, you'll need to do that when updates happen as well. Once the installer's done, it'll be easy. It'll do it all for you. But until that time, you need to be doing it the hard way. Without further ado, let's move on. But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. Well, I'm very happy to be making this video today. This has been a long time in the making, much longer than I wanted. Some of you may know I've had some serious health problems. I'm partly over those. Let's say no more and move on. This is the alpha release of H4AsyncWebServer, which has a working WebSocket implementation and also server-sent events. Removes a lot of the problems with other well-known libraries of similar names, and without further ado, I'm going to run through the demo programs that come with the alpha release, which will be out later today, the 20th of October 2021. So here's most of the code. We define a WebSocket handler, we add that to our server, and then we begin. And there's three main events here. There's on open, when the socket connects. There's something to do when we get a text message from the socket, and then every so often, using an H4 ticker, we broadcast some text to the socket. So we've got the two-way communication in operation, and as you can see, we've got 1, 2, 3, 4, 5, 6, 7 socket messages every time we do a broadcast, and it's once a second at the moment. Oh, hang on, no, it might not be. I might be lying to you. What's tick? Yeah, tick. No, tick's 1,000. So yeah, so every second we do those updates. Here we are then. Here we are. Any of those who've been around my software and firmware for a long time might recognize that graph. I stole it from Esparto. It just gets a random number. That's random number 1. Random number 2 and 3 are just textual. I couldn't be bothered. It's all cheap and cheesy. But as you can see, the millis are going up every time. The heap is static at 41k, which isn't bad for an 8266. And we have a feature here where if we type data in there, hit go, we'll receive the message, and that just sends the text back to the socket, which will update this message here. So I'll just show you that working. Blah blah blah. There we go. Click the button. Blah 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 was sent by the user. So there we are. Bidirectional sockets working properly and working at high speed. I could reduce that tick and show you it. I've had demo code running at 30 or 60 updates a second. Either way, it just kind of works. As with all of the H4 server things, you can quite happily create another instance of it without causing too much problem. Obviously it takes a little bit of heat, but as you can see there, other libraries like to boast that they're really quick. I think that's about as quick as you can get, and for reasons that you'll see in a minute, it's actually a lot quicker than other libraries. But there we go, and you can see here that while the random numbers are the same all the time because they're being broadcast, the specific text message gets sent only to the socket that sends the incoming message. So that's the WebSocket tester. I'll just load up the server sent events tester, and I'll be back with you in a second. Here we are then, back with the next option, which is the SSE tester. As you can see there, it's taken a lot of its styling from H4 plugins. In fact, it's a straight lift, of course. I'm still working on getting that going, but this is just the raw web server. It's not actually using H4 plugins, it's just using this very basic code here. A very similar setup. We create the SSE handler. When there's a change in the number of clients, we use SSE to send data to some JavaScript in the page, which basically adds each of these fields. This one here is a special one. This is all part of the JavaScript. It's so that we can simulate LEDs. None of this stuff works. I've just gutted it so that we can get the SSE parts working. The reason why there's so many was because originally this was for a comparison, because in the other library, if you have more than 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it fails. It just ignores everything after the 8th, which is why I've padded this one out. But there we go. Look, all that's happening is that every half a second this time, so we're sending 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're sending 11 updates every half a second. So basically we're sending 22 SSE messages per second, and as you can see there, we've got over 40k. It's flickering a touch, but it's otherwise not batting an eyelid. Other libraries would be choking on their breakfast and running out of heat. As with all of them, just to prove the point, we will then create another little instance of it, just to give you an idea of the of how flexible it is. When I say flexible, I mean fast. There you go. That's how long it takes to load the UI. And that, so obviously, yeah, we've used about 2k of heap there, but we're now sending 44 SSE updates per second from the device itself. No noticeable lag there, I don't think, is there? I could open a third window. I could open 5, 6 or 7 windows if I wanted. It's great fun. But talking about multiple windows brings me on to the next little demo program. So hold with me for a moment while I get that one running. Here we are back again then with a demo program I call Full House. The reason I call it Full House is because it is running 1, 2, 3, 4 separate servers within the same ESP. So the main web server on port 80 is very much the same, as you can see, as the previous example. I've just cut out some of the junk from the UI there. For a bit of variety, as you can see now, we're running on ESP32 this time. It's the same library for both platforms. All of the H4 libraries work on both 32 and 8266. You don't have to have 2 versions for each, which is nice and simple. When the installer's finished, it'll be even simpler. But there we are, just to show you how easy it is to write your own servers. We've got a discard server, which basically throws away anything it receives. just a sinkhole, a black hole. It's good for testing though. You get an echo server. I'm not going to show you these running, you just trust me, they do. Echo server just throws back anything that gets sent to it. So both of those are very, very handy in the early stages of development to check that packets are getting sent and received correctly. But my favourite here, look, is my little random quote server, which is running on 8017. Let's just look at the rest of the code. It's fairly, you've seen that part of it already. But we just declare those separate servers and then basically just start them. That's all there is to it. So let us open up port 8017 on this server. 200 port 8017. Oh, there we go. A dead yak never flies at night. Well, what a surprise. It takes 47 muscles to frown and only 12 to pull the trigger on a sniper rifle. So every time you refresh the page, you get a silly message. There's only about 15 of them. You'll get duplicates. They're not very funny. You can, of course, support me on Patreon. That's always a good one. Every little helps, as they say, and etc, etc. So there we have the full house, and finally I'll show you one more, and then we'll talk a little tiny bit about some side benefits of the new H4 libraries, as well as just working unlike other libraries, especially in respect to WebSockets and SSE. Pause and we'll be back with you in a second. Okay, we're back here with Form Handler, still running on the ESP32. We've just got a very small cut down form, and basically anything you type in there and then click on run gets sent via a post, an HTTP post to the web server, and that then responds by either refreshing the page back to the same page, or if you type H4 plugins, it will redirect you to H4 plugins, of course, which is where this all leads eventually anyway. So very little in this. It was mainly to show to people how to put in additional paths or routes onto the server, and also how to handle posts. And when the post comes in, it basically just tells you the full URL that it came in from. It prints out all the parameters that it came with, and then it prints a raw hex dump of the body data, which will be the parameters in this case because it's a post request, and then it will either redirect to H4 plugins or back to itself if it's not that. So it doesn't do much, but it does show you that post and various other things work and how to use them with the new syntax for this library. So let's just give that a quick try. Let's just first of all put in any old nonsense. We'll do that, look. And what we've got there, look, is we got, that's the URL that it came in from. 3 parameters, the reply, which is the text area box, command, which is what we typed, and there's a hidden, you know, if you can look at the examples you can see the HTML, but there's a hidden field in there called secret, not anymore. And then there's a dump of the data, which you can see just contains all the things and does what it says on the tin. Right, let's just move on now then. Let's go to H4 plugins, show you the redirect working. So it does all the same as before, and then jumps you to the GitHub for H4 plugins. Okie dokes. Now we're going to look briefly at some side benefits of all of what you've seen so far. 4 little demo programs that you can have fun playing with, and then we're done. So bear with me a second. Side benefits, right. I know that's too small. I'm not expecting you to read it. You can look at that link at the bottom of ESP Async Web Server. That on the left is the example given on the website of how to handle a WebSocket. And as you can see, it's quite involved. The example on the right is how H4AsyncWebServer handles a WebSocket. So the side benefit is manifold. Manifold, excuse my English. Your code's going to be a lot smaller, a lot cleaner, a lot quicker to write, and a lot more intuitive, because there's a number of problems with both the WebSocket interface and the SSE. I'm not going to go into massive detail, but it's such a difference that it has to be said, because this is a bonus. And it's why they run that little bit faster as well, because as well as being 70 odd lines long, this has a number of issues with it, and they are this: that there's 2 exit points for the same type of data, because there's one that deals with a short message and there's one that deals with a fragmented message of the same type. There's a built-in buffer overflow ×2 in each of those things. It's a fatal error. It's one of those ones that if you're lucky you'll get away with it, but basically the code is very, very badly written. That is a schoolboy error. He's basically dumping a 0 off the end of the buffer without knowing what's there and overwriting data. Possibly one of the reasons why that library is so unstable, because it depends. You guys know what I'm talking about. So as well as that, as well as all of that, it expects you to reassemble the packets. So you have to know intimately to the last bit a very complex protocol and reassemble packets when they're fragmented. Library doesn't do that for you. Also, it doesn't do the keep alives for you either, so you have to do those too. Now, I'm not going to carry on. I'll end up ranting and getting angry. Suffice to say that H4 automatically reassembles the packets for you and just calls you with a text message or calls you with a binary message. And when you want to send one, you call send text message or send binary message. It really couldn't be a lot easier. And it also manages the keep alives, because it's a fundamental part of the protocol. It's what the library should be doing. What this library thinks it's doing is beyond me. And before we finish, just because it has to be said, that you see that difference, having seen that difference and seen the speed at which it works, you're not going to believe the next slide. So I'm going to put it up and finish with it anyway. This is just a quick summary. It's not a direct comparison. There are so many differences between the libraries. You'll see why. Because I refuse to follow the patterns and procedures used in those other libraries, because they're wrong on so many fronts and they lead to the problems. But what I've done is, as close as I possibly can in terms of functionality, I've counted the number of lines of code, SLOC it's called, for both the SSE and the WS implementations in ESP WebServer. So what is happening here, I don't know. There are 1,600 lines of code in the WebSocket implementation of Async WebServer, and they're broken, and it doesn't work properly, and they're unstable, and they got bugs in it, and they don't do all the stuff that I showed you that it should be doing, like the keep alives. So H4Async corrects all those issues and does all that other stuff for you automatically, and is a grand total of 169 lines long. That's almost 10 times smaller. I just don't know what the person that wrote that was thinking. I really don't. I kind of made some guesses. There's a guess, but I just don't think the guy understands how the protocol works and what it should be doing. I don't think he understands how the underlying libraries work. I mean, he's got part of that 1655 lines is like just absolute pages and pages of code that he just does not need, that can get done in a single function call if you know what function to call. So he's reinventing the wheel over and over again. So he's got a vehicle with one square wheel, one triangular wheel, one normal wheel with a flat tyre, and the other one hasn't got a hub on it. It's utter nonsense. I just don't understand. I mean, you've seen the demos, you've seen it working, you know that the H4 Async Web Server does it. It does it in 169 lines of code. This does it badly in 1600. Same on the SSE front, not quite as bad. There's so many issues with the SSE. The interface is completely illogical. It does tons of stuff that it doesn't need to do. It makes you do tons of stuff that you don't need to do. It fails to implement the protocol properly, again because I don't think the guy understands it. They use the wrong data type. They've got bugs in them. I'm going to stop there because I can feel myself going into a rant, and today should be a happy day because at last we now have an asynchronous web server that talks down through all the H4 libraries directly to LwIP without touching any code written by the author of Async Webserver. No ESP async TCP, no async TCP, works on both 32 and 8266. It's bound to have bugs in it of its own. It's alpha. Help me fix those and we'll move on together to some much more stable apps on 32s and 8266s. Hope you've enjoyed this. I've loved it and I'm sorry it's taken so long. As always, thanks for watching. Please remember to subscribe, like, click the notification button and support me on Patreon if you can. Thanks and see you next time.